Hello YouTube, and welcome to my video on Python getting started principles for agent-based manufacturing. In this tutorial, we'll be just showing you the fundamental principles about creating an agent-based model from scratch using no additional packages, just pure Python code to model agent-based systems. What do we mean by an agent-based system, manufacturing system? Well, we can start off, we've got this world that we live in and we want to produce items in that. We have a series of machines that are distributed across the world in different locations. They might have different manufacturing capabilities and they have different materials they require, different processing steps that's needed, different materials. And we want to then also be able to get jobs that are required across the world to those machines. So typically, of course, we have our supply chains that coordinate all this work for us. In our case, we want to see if we can get our machines to talk to the jobs themselves and then to coordinate amongst one another. So we do this by using agents or artificial intelligence agents. So we have been developing, as part of our research, different types of artificial intelligence agents that can represent jobs or act on behalf of machines, and they can join a network together, using the internet. So joining the network together and can communicate and share their needs, their wants, their desires, and broker the work so the right jobs get given to the right machines. And it's an entirely autonomous network, so it just happens. You can submit your jobs, their constraints and their requirements, and the AI that represents that job in this network would then go and bid and broker with all the other machines. To do this, we use agent-based modeling to test out different types of AI agent and different ways of coordinating work and brokering work. In this tutorial, we'll be just showing you the basic principles of how we might, represent machines and jobs. And this will be a simple case of jobs going to a global imaginary queue, and basically the machines are just going to be pinching those jobs from there. So there's no actual going to be kind of artificial intelligence communication here and no bartering done. We're just going to get the world set up, get the machine set up, get the job set up, and some basic communication between those sets of agents going. And we're going to do that all in Python. So we will start off with a blank folder. Here we go with our main script, which we're going to be putting our runtime logic in. So yeah, as long as you've got Python installed, just create yourself a folder. We'll not be using any other packages, just the basic packages that come with Python to create this model. To start off with, we'll create a folder. We're just going to call this our model folder. Again, these are kind of arbitrary. You can call them whatever you like, but this is where we're going to host all the model code. And then our main is going to be our main runtime, where we're going to execute that code. In that, we want to create a new file called world, and this is going to create our first class, which is going to be the world class, which can represent the world, where agents are going to join and be part of this world. It's going to manage time within our agent-based model. So as time increments, agents will go and do actions. They will send emails and communications with one another, and then other agents are going to have to handle those messages. So the world is our way of passing those messages between agents and the agents being able to find each other in the world. To start off this, so we then create a class, and we're going to call it world. And in it, we're going to have a private variable called now, which is going to just represent time. What time is it now? And we're just going to set it as an int. You could use date timestamps or even a float. I'm just using int. It's an arbitrary instance in time that we can increment. You could then change that to represent milliseconds, seconds, hours, or days. So we have now as our time. We're going to have our agents. The agents are going to connect to this world. So we're going to create these as it's going to be a dictionary of integers mapped to what we're going to call. They have to be of a class. We're going to call it base agent. Every agent that we create is going to inherit this base agent class. We'll create it in a moment. And to represent the fundamental functions that they need to have to operate in this world, or for the world to operate those agents and call them. So we'll create that in 2 seconds. We will also have a utility function here, utility variable. We're going to go agents by type. And this is going to be useful when we want to try and find a list of a particular set of agents. And we'll define them in a second, and I'll define an agent enum. So they're going to be a type. It's going to be an enum of different agent types. And this is going to be then a list of integers. So what we have a dictionary of agent types. So we're going to have machine and job here. And then we are going to have them, each of those keys is going to be then mapped to a list of integers, which are going to be the IDs of those agents. So when we create an agent, we're going to add it to the world. We're going to find out what its type is, add that ID to the agents by type. And we're also going to add it to the agent's dictionary as well, which is actually going to be where the agent is held. We will also create a messages variable, and this is also going to be a dictionary, and that's going to have an integer, and it's going to be a list of something that we're going to define in a moment called message. How our agent-based kind of model works is that we have these agents that are going to be calling every time step. They're going to be calling next on themselves, which is like, what am I going to be doing now? And they're going to check their status and do something based on their current status, or maybe not. They just stay dormant. But if they want to communicate with one another, then they can send a message to each other. So we're going to define that message class. And this dictionary here is where in time is that message sent. So the agent who's going to create that message is going to submit it to the world as if it was going to send it across the internet. And it's going to give it as time. It's going to be, for us in this simple case, we're going to just say the next time step, we're going to put this message in. And when the world increments that time step, it's going to go and, I've got these messages, I need to send them out to the other agents to handle, and they will respond back. So our messages dictionary is just a way of storing those messages for the world to be able to send on, almost effectively just brokering those messages between the agents. Right, so those are the fundamental variables within our world. I think now we need to define what a base agent is, the agent enum, so what agents we exist, and what the message looks like. So let's start with our base agent. So we're going to call this base agent.py. Okay, I've put an underscore there to say actually we're not going to want to call this outside of our class. It's just a way of saying it's a private class to be used within the model itself, because we're going to build a machine and job agent upon this base class. So what we want to do is then let's start with defining the types of agent that we want to have. So we said about this agent enum, and it's going to be type string and enum. Okay. And we're going to have the job agent. We're going to define that as job machine agent. That's it. So those are going to be our fundamental types of agent that we're going to instantiate in a moment. Now let's get to creating that base class. So we have a class called base agent. And in this, we're going to have a set of variables, five variables, one being the world. So we're going to want to import the world. And in this case, we don't want to just import it directly because we want to do it only for type checking. We're not actually requiring to use the world here. It's just for type checking. So if we do if type, capitals, there we go, if type checking, and the autocomplete should help us there. Import type checking, and we'll import the model world, so we can use it as a definition here. World is a representation of class world. We do say this because if we start importing them directly, we'll get to a case of circular arguments with them all referencing one another. but all we're actually interested in is using it as a type to say this is of this structure. We're not actually going to use it as an instance. We're going to have a debug variable, which is always quite useful when you want to do debugging, turn debugging on, let things print to console. They're going to have IDs, which is type int, type of the agent that it is, and this is going to be that agent enum. And we can find, I think that's all actually we need at the moment. We can define additional parameters that might exist across all agents, like such as messages sent or received, if you want to try and log those, if that's something of interest to you. I think to get it all up and running, all you need to know that the agent needs to be connected to the world. We got some ability to do some debugging if we wish, but it needs an ID, so it's going to have its unique ID, which is just an integer in this case. And we're defining type. What type of agent are we having here? So if we wanted to define an agent, we need to define the init on the class. So we've got the self ID. It's going to accept an ID the int. It's going to accept the type, which is going to be an agent enum, and world. So it needs to have accept this case of it enum world, and then in this we are just going to set these in our space. So world debug equals debug. Oh, I haven't added debug in there yet. Go in there, debug all, and we'll default to false if not added. Yeah. Debug. But that should be lowercase world. Oops. There we go. We do self ID. ID. Self dots type. Yep, the agent type. And there we go. So all we're doing now is just instantiating all those variables that we've defined up above here. So that's our initialization function. And because they're all private, if we want to get those information out, we can then define some functions to call those. So if we want to return the ID, we can create a function called ID and just return self.id. Now you could have those as public variables and just access them from anywhere you like. The reason why I put them behind private is as you're building up these models, it's quite nice just to hide everything, to say only expose the things that I intend to use or want the other outside world to know about. So it's just a way of, as you're building, your syntax highlighter, your linting can save you there. So we can do that for type as well. Let's just put these are all just some utility functions here then. So we can return our self dot underscore type. And then the fundamental functions here that we're going to create now are basically how the agent's going to work within the environment, operate in the environment. So all agents will need to have the next function. And the next function is for every time step, the world will iterate through all of the agents. You can set it up to just randomly pick agents, or you could just keep a list in one structure, one format, and you just go iterate through them in a consistent manner. The choice is up to you. But every time they're going to go call next, then the agent can do something in that space. The default agent here is not going to do anything. It's not going to check its status. It's not going to do anything in this world. It's just going to exist. But all agents will need that next function. We also need to create a message. Okay, reinsert message function, and that has returned. this is going to enable our agents to accept messages and return them in some shape or form, or do something to them. They could either respond to it by send another message through the world, or they are going to update their status or do something, maybe, or maybe nothing at all. In the case of the base agent, again, nothing's going to happen. This is just going to exist. It might accept messages, but it's not going to change its behavior or do anything differently. So that's our base agent class that we're going to then build and instantiate all the other agents. The other one we want to create now, the other, say, base element, is going to be our message. So we'll click that as a message. EY. So this class, I'm going to call it is like message. It's okay, cool. Typing. Save that one. Well, we'll come back to that in a moment and clean up those error messages there. All these error messages are coming up because we haven't, fully defined all the classes and connected all the dots just yet. So we've got the class message. So we want to do from agent. So in each of the messages, we're going to say who it's from. And we're going to define 2 agents. So in our little demo here, we're going to have the opportunity to send it to 1 or more agents. And in the case for our agent-based manufacturing, you might have a job that might want to call out to say, hey, any machines available? Or the machine saying, hey, are there any jobs available? So you want to call out to all of those. So rather than creating multiple messages, each individually, to each individual agent, we set them as a list there. We just then have one instance of that message, but it probably we have a list of agents that it should go to and who should receive that message. We'll have a subject, just to give it the kind of type of message that's going to be sent, and we can define some of those now. So in this demo, so we go, just grab our enum, import enum. Okay. We are going to have jobs saying whether they're available. We're going to have machines going, hey, are there any jobs available? So it wants to send out any available jobs. We're going to have a subject saying that I've been selected. We're going to have a accepted, declined, and completed subject. So jobs can say they've accepted an offer or declined an offer. Machines can send out whether they're checking for availability, whether they selected a job, or they have completed a job. So the job can update its completed status. So these are the subjects of our conversation. So we're going to find one that's available. This will be sent by the jobs to say that they're available. We're going to have one called availability check. Can't spell today. There we go. It's availability check. And that there. This is for the machines to say, they're going to send that out to all the jobs and say, are you available? Yes. Okay. I will. They will respond whether to say they are available or not respond at all. It's only going to respond if they're actually available. We have a selected. So this is going to be sent by machines to jobs to say, I've selected you. And then a job can say whether they've accepted the offer. Maybe another machine got accepted another machine in the time it's taken for the message to be sent around the world. You can add things like lag into the system by that message exchange. So you want to have that response say, yep, I've accepted, or maybe I've declined because I had a better offer from another machine. And then we also have the completed state. So whether we have successfully completed a job, machine will send that to the job, and then the job can update its own status. And alongside that, we could have like what sometimes it says it's the body. I'll just call it data for now. This is some like additional fields which you could type But here we just keep it simple. It's a set of string and integers. So here we'll be submitting things like print time. So the machines could look at print time and say, make some justification of why they picked a job over another. But here we're just using print time to say, okay, I need to be out of action now for the next few minutes because I am currently printing a job. What we've got is now a world, a message that can be sent by agents, and the base agent class that we're going to create our job and machine agents. So just before we go on to creating those agents, we want to just tidy up some of these connections here, these links. So this type message, we can now import that in. So that autocomplete there is just imported it in. We can import here that base agent enum message. There we go. So we have now imported those. Now it's all connected up. Our syntax highlighting is all happy. Right, so if we go back to the world, because we haven't fully finished, we've only just defined the variables within it. What we can do now is start building out all the functionality of the world, and then we'll get onto the job and machine. So we want to define the job, define the world, sorry. Initialize the world, let's say. So in itself, don't need to no, just no. And we're going to say self now equals 0. So this is just going to initialize all these variables. So self dot, it's got agents by type. Get to that one in a second. I just wanted to do the agents first. Here we go. Define this one. Self agents by type. We want to do agent enum dot job, and it's going to be an empty list. And agent enum machine, and that's going to be a list. So this is going to become in handy when you'll see that the machines will want to get, well, where are all the jobs in the world? So they'll send, rather than us send a message out, we could imagine that there's already like these agents have connected to some kind of network and an address book, and they can just query that address book and say, oh, I can pull down the list of agents that are jobs. We could have added a generic message that sends it out to everybody. So anyone connected on that network, it would just go to everyone and say, if you're a job, you could respond to that. So all of these things are things that you could manipulate, change in your models. We will now define the messages structs as well. So again, all of them are empty. We haven't added any agents yet. Time hasn't incremented in any way, but now we've just got this empty world ready to accept new agents and start running. A couple of other functions that we need for the world to operate. We need a function we call tick, which is just going to increment time. And do self now increment by 1. So we're just incrementing time there. And we're going to be able to report the time. So remember, the world's going to be, agents are going to connect to the world's going to be connected to the agents. So they want to be able to somehow query time and what time it is. So they can query the world and find that out for themselves. There we go. So return, no. We can have a reset function here. So if you wanted to do multiple studies, rather than having to reinstantiate, we could just reset the function. So reset the world. See, so oops, getting ahead of myself. I'm looking at my reference here. So this one's now equals 0. If I can just copy and paste it in it over here. So that's just our reset function. We can start with a fresh world, add new agents to it, and off we go again. So something that the agents can do is going to go and give the world messages, but then for it to distribute in different time steps. So I'm going to create a function here called add message, and we're going to get the time, and We're going to now check. So what we want to do is we've received, we're going to, sorry, we need to message here. Right, so we're going to receive a message from an agent. We are going to then increment now. When are we going to send it? We're going to say, call this, let's say, send on. We're going to send this message on the next time step. So whatever time it is now, +1. We're going to check if send on is in the self.messages dictionary. And if it's not, we're going to have to create that entry. If it is, then oops. If it is, then we are just going to then append it to that list. So self messages send on append message. We're going to append that message. If not, we're going to have to create the dictionary entry. And we're going to default with that first message. So that's going to be the first message that's going to be sent in that time step. That's adding messages to the world, so agents can send those on, and now we need the world to be able to give those out in different time steps, or when it increments into that time step. We can do that by defining a function called send message. And now we're going to go, okay, let's find out what now is. Okay. And if now in self.underscore messages, we're saying, is there a dictionary entry for now? So therefore, we must have a list of messages to send. If so, we're going to go iterate through that list of messages for message in self.underscore messages now. And we're going to go for ID in message to agents. Remember, we've got potentially a list of agents that we might need to send this message to. And we're going to do, first of all, we'll just do a quick check to say if ID not in self agents or name agents. Then we want to exit and say, it's some kind of warning here because we expect the agent to exist. Maybe there's something wrong with our code when we create the agents. Or maybe you do expect them not to exist. If not, then you just don't send it on. But in this case, we will expect that we have created the agent that we're sending it to. So we could say agent not in population and received ID. Oops. And then we want to make this an F string. We're going to exit the program just to say, oh, okay, something's happened here. We didn't expect to receive a message ID to an agent that doesn't exist. So we'll exit and also return that to the user. Maybe they can use that to debug why they've created, why that ID might not exist. Else we will just go to our agents dictionary. We should be in our agent dictionary, and we can then say receive message. So we're going to call that function that all the agents have, and we're going to pass it the message. So we're going to send that message on, and the agent's going to do something with that that information. So that's send message. The next function we want to do is the call next. This is going to go look for all the agents and call their next function. So they may have not received messages, but at each time step in our model, we're just going to say check your current status and may or may not do something based on that current status. So all we need to do is for agent in self.agents.values. So we're going to iterate through that list. We're just going to call their next function. Again, all the agents, because they're going to be based off that base agent class, are going to have that next function, and maybe do something based on their current status in their cycle. And the other one we want to do, and this is just more of a utility function, again, just the case of how we want to set it up, but it doesn't need to be in every model. We're going to call it IDs, and this one is going to accept a variable called type. So this is going to be used again, like effectively to look up the address book and return the agents that are of a certain type. There we go. So we're going to get all the IDs for the certain types. This is going to be useful for our machine when we're going to go, oh, I want to see if what jobs are available. I'm just going to query the jobs agents and send that message out to all of those. So that's our set of fundamental message functions that we need for the world to do our basic, kind of agent-based model. It's going to tick through time. Yeah, we'll tick. We are going to be able to report now and say what time it is now. We're going to be able to reset ourselves. Agents are going to be able to use this add message function to add messages to the world that the world is going to send on. It's going to have this send message function that we're going to call every tick. Every time we're going to go and send all the messages out that are in that time step to all the agents to deal with. And we've got this call next function that's going to call all the next functionality of all the agents to do whatever they need to do based on their current status in time. And then we've got this utility function called IDs, which really retrieve the IDs of a certain type of agent. So those are all the basis. And now really we need to we can, with that, that's like almost the fundamentals. Now we can create all sorts of agents and have them sending messages. In our case, we've got machines wanting to pick jobs that are in the network. So I think the first one we're going to do is do the job. So we go and create this class job agent. I'll call it job. And he's going to be inherit the base agent class. And in this, we're going to have the job's going to have a status to say what type of status it is in. So we're going to have that as job states enum. And if I scroll up here, class job states enum. And these are all the different states that the job can exist. So you can imagine typically we use PowerPoint or some kind of drawing app to create our state charts. And if you ever use tools like AnyLogic where they produce their agents through state charts, that's effectively what this enum is. It's just going to be the different states that the job can be in at any one time. So in this one, we're going to have when the job is created, it'll be enter this available state. When it's selected, in the selected state, and then we'll have the complete state where once the printer has printed or the machine has manufactured the item, it'll send a message to say you have now been completed job, and it enters its complete state. So that's the life cycle of a job. There is no kind of agents here today. We're just, like you say, creating a very simple process of a workflow of like, okay, available, being selected and being completed. The machines are just going to be like kind of first come, first serve, just grabbing jobs from a pool of jobs that exist in the world. So that's its status. It's going to have a print time, and we can define that. And often we just use some kind of random distribution here to create different job distributions and workloads for our agent-based models. We're going to have some logging information here. So when was it submitted at? When was it selected at? And manufactured by. And completed at. So these are just, again, likely information that you might want when you're trying to track and trace jobs through these agent-based models. You can have as much information or as little information as you'd like to capture along the way. These are just like, say, it needs a print time. It's going to have to communicate that to the machine to say how long it's going to take to print. When was it submitted at, selected at? So those are good for looking at the distributions over time, and who is it being manufactured. If you're interested in which machines are performing or outperforming others, you can see the lists of different jobs being taken by different machines. So we need to create a init function here. Oh, there we go. It's already created our function for us there. Nice and well. We need to import these. Enum, world. So we need to accept all of those. We also need, so we've got the ID there, print time. Okay, so time, we have to define that as we define our agent. So we want to define that, just pass that over to the class. And we want to say it was submitted at world.now. So in this case, we're going to create it we're going to loop through and maybe create them periodically, these jobs. So we can just take whatever the time is of the world at that point in time. You can do, predefined lists. So you could do these submitted at prior to the world being created, and they kind of exist in the world, but maybe you could have a dormant state until the world has incremented over that time, and then when it's incremented over submitted at, the agent comes alive. So you can either preload it or create them as the time goes on for your model. Self._status. Now we just need to say what status it is, and it is going to be, we're going to default it's straight. We're going to add the job, and it's going to be available for machines to pick. So what we need to do now is override the core functions, the next and the receive message. So we define next, and actually for the job is got, as I say, minimal to no intelligence here. It's not going to do anything. It is just going to respond exactly to what the machine requests of it. So we can have we can just print out this. It's be a bit for debugging and logging. Self.id as for the next function. There we go. Maybe we can respond and print out what the state is. This is not necessary for the system to run, but it's good for us to debug, and you'll be able to see some of the interactions. So that's that, and we can return that then. So that's all done. And we need to now override the receive message function. So we need to import message. In some of these cases, like say for this job, for example, if you wanted to, you could have that within the base class, and actually just as this is done, it's called super. So that will then call the function before the base agent function. So maybe you just want to append some functionality onto a function that's always occurring for all your agents, nonetheless, regardless. So you could do that. In this case, we're just going to override them completely. So receive message. Let's just copy and paste this over. So we're going to just print out that we received the message, and we're just going to say message received. And if I can spell, there we go. So message received, and now we've got to handle this message in some shape or form. What we can do is then do a match on the message subject. And we can do look at different cases. So here we go. We know we've got our list of subject enums that we are likely to receive. So we want to, for example, do the availability check. So job might receive, are you available? So what we want to do is if self.status equals job state enum available, then we all want to respond. If it's any other state, we're just going to stay quiet. What the machine's going to do is going to send this checkout, and then it's going to sit idle for a predefined number of steps. And then as it receives messages back, it's going to append those to a list. And once that time has passed, it's going to pick one on that list to be selected. We only want to be added onto that list if we actually are available. So we are. So what we want to do is reply to that message. So I'm going to create a variable called reply. I'm going to say it's from agent. It's going to be us, so self.id. _ID. And we're going to have two agents. And it's just going to be the message.from agent. There we go. And we're going to pass the subject enum dot available. And we're going to pass some data. And in this data, we're going to do print time. We're going to pass it the print time. So you could imagine that set of jobs are going to receive a load, set of printer machine is going to get a load of jobs with different print times, and it may use that to then decide which one it might want to go for, print itself. I don't think we'll be using that in this base example today. But we'll do add message and reply now. So what we've done now is create the message that we're going to reply to. We've given it to the world. The world will append it to this message queue. When it gets to the next time step, it will get sent out to the machine. The other subjects that we need to be interested in are selected job. If self.status equals jobs.enum available. If it's available, so if we're still available, then we want to, let's give this bit over. We want to say, we have accepted the job, so we're still available. So what we've done, we've just received here, is that we received the selected message from one of the machines, and we want to say, yep, okay, we've accepted that because we are still available. Else, then we want to do, so of course we've got some metrics that we want to capture. So we want to capture well now. Of course we want to say, oh yeah, we were selected at this time in the world, and of course we need to change our states. We need to move to a status that we are now in the selected mode. So then of course we'll then respond to other actions appropriately because now we're in the appropriate status. Otherwise, if we are not in the available state, we all want to say we've declined because we have either been selected by another printer and have accepted that job, or we are completed. So we'll just need to reply to the machine and say, no, we decline your offer. Please go and find another job to print. And we need to also then paste this over, send that message back into the world, picked up. Then there's the case of subject enum dot completed. And we'll receive that by the machine once it's completed our job. So we then want to grab, and we'll put this in the job message later, you'll see. So when the machine sends that job, we'll also append some data saying when you were completed at. So then the machine can update that. The case where I want to get it from the message rather than get it from the world is some of the models that we do is like look at lag, look at time delays between sending and receiving messages. So you want to have the time that it was actually, machine says it was when it completed, and then you can imagine some kind of traversal of the network of some data. It might have taken a bit of time to receive it, so it's going to be an additional time step or additional bit of lag on top of your completed at time. We want to get the original completed at from the machine. So that's that. Then we need to change our status to job state enum dot complete. And the final thing is to deal with any other cases. Our machine, we expect how we've created this, how we've defined our model is that the job should only need to respond to availability, selected and completed messages. If it receives any other messages, we've coded something up wrong. We've got an error somewhere. So what we want to do is define to say, job .id could not have received this message, and we can then print out message subject. There we go. And I'm missing a say. So what we're doing now is saying we should not have received this message, and giving back the user the subject of that message, so they can help again debug model. And that is the core logic of the job. So like I say, it's just going to respond to machines. There's no intelligence in itself. So what have we got here? Let's just go through it quickly. We've got the job states enum. The jobs enter, start the world as available. They get selected and they move to completed states. So we have a status that we want to keep track of in the variables. We also have some variables that we want to keep. So each machine job has its print time, and then some metrics that we might want to capture and log and do some analysis post our model running. So when were jobs submitted at, when were they selected at, who were they manufactured by, when they were completed at. We created the initialization function, and then we overrode the base functionality of the base agent for the next and receive message functions. So the next one just prints out that the job has been asked to do something, but of course the jobs don't do anything in there. They don't have any agency in them. All they do is receive the messages and respond to those. So in our receive message class, we're looking at availability checks, selected messages and completed messages, and responding to those accordingly. Any other messages, we will exit and say we should not have received this message. We're nearly there now. Like I said, so we've got the world, base agents, messages, jobs, and now we need our machines to gather those jobs. So we'll create our machine, and this will be our final file for the code, and then we'll create a little runtime to demonstrate how it all works together. So just as the job agent, we're going to create this one's machine. It's going to be inherit the base agent class, and it's going to also have a status. This is going to be of type machine status enum. Machine status enum. It's going to be a string enum. There we go. We're going to have machines that are available. We're going to have machines that are waiting for replies. We're going to have waiting for acceptance. And waiting for acceptance there, and we have printing. I'll go for this logic for you now. So the four states we have machines that are going to be available from start, looking for jobs. They're going to send out a who's available. They're going to sit idle for X number of time steps, waiting for replies. So messages might be received then. They're going to append those to a list. And then from that list, they're going to then pick a job to print. It will then say, hey, I've selected you. And it will then wait for acceptance. So it goes into waiting for acceptance. We're going to wait. Hopefully, we're going to receive a, yep, the job accepted us. And then we'll move to the printing state. If not, we'll go back into the available state and repeat that process. We will then continue. And if we enter the printing state, we're just going to keep printing until we've printed the job. Then we will then return back into the available state. Those are the four states and how we progress through them. So the other things we're going to have here are then the jobs. So this is going to be just a nice list of jobs that we've completed. This machine is completed. Another variable that we could access and do some data analysis on. We're going to have a timer. The timer is going to be used for the waiting periods, waiting for replies, waiting for acceptance, and for the printing. So all of those have some level of delay. So we're just going to have a single timer that we're going to update according to each of those states that we move into. And we're going to have replies. And that's going to be a list of ints. So is it anyone who's replied? What is their, what's the ID of that reply? Because we're not doing any logics here, or we don't need to get any access. This could be the list of messages. And more likely it would be the list of messages, because you might want to then take out the pieces of information such as print times and data there to then do some reasoning about, have some intelligence behind why you're picking the job that you are. In this case, like say, we just want to build the functionality out today, get you up and running, and then you can build whatever intelligence you'd like to in the models. So what I'm doing now is just creating the initial let me finish typing. So we're just going to create the init function. So this is initialize a job. So we're going to say self-dots. We need to status. Sorry, not some. We're going to do machine status available. We need to import world. We're going to do self underscore timer 0 self dot flies imports empty self dot jobs. Okay. And we then have to do our super init, initialize the underlying class as well. ID agent and world. Oops, the type's just this functions type. Oh, this is going to be agent enum dot g. There we go. So what we've done is just initialize the status, time, and replies and jobs to all just empty fields. And then we pass the ID, the machine type, and the world to the base agent. Of course, then that's going to instantiate the ID and type for our, and the world for our agent. This one has a bit more logic to it. So what we have is that next. So this is this agent actually going to do something every time step. First of all, let's just print out that we are actually calling this machine. So we're going to do machine within the brackets. Underscore ID. Next status. So what to do, every next step we're going to just report the status of the machine. We also need to do some logic and say what status is in the machine, what do we need to do next. So self.status. If the case is the machine, machine status is available, then we want to just reset our replies, make sure everything's cleared out, reset our timer, job IDs equals world IDs. What we're going to do is just go and query the world for the IGs to send a message to. Again, we could have it to send to all, and of course, if the machine receives the message, it's not going to do anything. The jobs receive a message and they're available, could respond. But in this case, we're just going to query the world to say, oh, I've got these agents. So yeah, let's get the job IDs for those agents and just send the messages directly to those. It depends entirely on like the kind of networking model that you're trying to represent. So we're going to say we're going to create a message and we're going to send it to all of those job agents, all those agents actually. I'll make it a bit more easy to see. There we go. Call that job agents. And formatting will clean up in a second. Subject.enum availability check, and data, we're not going to send anything with that. There we go. So we're going to create this is already a list, so clean that up. So what we're going to do is create a message from ourselves to all the job agents. The subject is, are you available, with no data. We are going to send that to the world, add message. And then we're going to do self.timer. We're going to give it 4 time steps for them to reply, knowing that they have to wait a time step to receive it, then create it. So on that time step, then they might reply. But then, of course, that will go into the next one whilst it passes through the world. So it's like a couple of time steps until you might receive the messages back. So self.status here. Then we're going to do machine.status, waiting for replies. So the next case is machine enum waiting for replies. And if timer 0, have we waited the allotted time? Then we will want to check if the length self_replies is greater than 0. We've got some job as some replied and said they were available. Then we're going to go and say, well, let's just pick the first one. So this is, again, very simple logic of, yeah, whoever is the first to respond, I will pick you. We will then create a message. And if I just copy paste all this out, and we all need to do is do selected. We've selected it, and we're going to send that to the job that was first in that list. We also add that to the world, so we send that back for the waiting for the job to reply, and we'll set our status into machine states.waiting for acceptance. Now we could add a timer there, so we'll wait for a period of time to say, has the job accepted? In our model, we do expect them all to reply, either saying yes or no. We're not expecting them not to reply at all. So otherwise, we would hang, the machine would hang in that status. But because we've got it programmed that they should respond, then we can just put in that state and be okay that we know we should have received a acceptance or declined. But that's something that you could explore. A lot of it is to say, actually, there's messages drop out, data doesn't get received, so you need to poll and try and send again in those circumstances. If we didn't receive any messages though, we will just reset everything and put ourselves into the available state. And then in the next iteration round, we will then get into the state of, let's send out a new we'll send out a new message looking for availability for jobs. So we'll just keep doing that periodically until we find some jobs that are available. If the timer is not 0, then we will just decrement that timer by 1. Okay. The next case is then machine status enum dot waiting for acceptance, and we are not going to do anything there. We'll just be sitting there waiting to handle the message, either we've accepted or declined by the job, and we'll get to that in the receive message function. Then we have the machine status that we are printing. So if self.timer equals 0, we will just copy this up here. We'll create a message. And it's going to be self underscore jobs -1. So when we get a accepted job, we will append it to the jobs list. So here we're just going to pick out that job ID and say, okay, yeah, we've finished that job. We will then send them a message to say that we've completed, and I mentioned before where that completed at. It is, well, it's here, completed at, and go to well.now and say this is actually when you were completed by the machine. We will then just do some housekeeping of just resetting the variables. So you can imagine actually having some kind of utility function just to reset these. It would be quite nice. And also we need to then change our status to say machine status available. We are now available again to accept some more jobs. We also haven't sent that message. So there we go. So we send that to the world. Else we decrement the timer again. That is our next function. Debug is off. We're not using the debug there at the moment, but that's how you put debug in, and we can then propagate it down through our machine or base agent. In this case, we're just keeping it simple and just not using it in this instance. So here for next, we will just print out what status we're in. If we're available, we'll send out the availability check message and then go into waiting for replies. If we're waiting for replies, we'll either decrement 1 if we're not equal to 0. If we're equal to 0, we'll check if we've received any replies. If we have, we'll just take the first one and say you've been selected. Else, we will just reset ourselves and go back into available state. If we're in the waiting for acceptance, then we are just waiting for a message to be returned by the job that we sent that selected message to. We're in the printing state, then we will decrement the timer if we're not 0. If we're 0, we will send the completed time to the printer through the message functionality to say, yep, here's your completed time step. And we will go back to being available again to go and find some more jobs. what we need to do now is create the receive message function. So we receive message, we're going to override the current functionality and say machine self.id received there you go, message subject. Again, this is just for our debugging here. I should probably use our debugging functionality where you should say if true, if debugging is true, then we'd print it. Just not going to do this for this demo, just to save a bit of few extra lines. So we've got our subject, so we just want to do a match on the subject. In the case that actually this one's got a little bit more complicated. We want to do a match on the subject, but also the self.status. So we've got to look at two different criteria. So for example, if the subject enum, so what I've done there is that what I've done is put it into a tuple. So I'm looking for two of these. So I'm looking at, well, what is the subject? What is my status? And I can do my tuple as a case statement as well. So I'm saying if I am available, not subject enum. Oh yeah, is available. No, that's right. So if let's say a job is returned with saying I'm available, and I am also in the period of waiting for replies, so I'm in the right state, then self.replies.append message from agent. Remember here we're just adding the ID here. We could actually add the entire message itself. Again, if we had some more information that we were going to base our decisions off, I'm just taking the ID to say, okay, yeah, I received an available message from this ID. I'm going to take the first one that replied to us as the job that we're going to select. So the other bit here is subject enum dot accepted. Machine status dot enum waiting for accepted. So here we go. Yep, jobs received, so we're accepted, and we also are in the right state, so we're in the waiting for accepted status. We need to then go into printing mode. Take that as our contract that we are going to print this job. And in this case, the print has also submitted in that data field the print time. So we want to update our timer. That's going to take us how long it's going to take to print this. We're going to update our status. Say that we are machine status printing, and we are going to add the message from agent. Oops. There we go, brackets. There we go. So what there is, we have updated our time, so now we're going to decrement that time as if we are printing this job. We are in the printing state. We set ourselves in the printing state, and then we do our jobs to say, yep, okay, let's add that agent to the list of jobs that we have done. We are doing. The other cases that we need to deal with is the subject enum where we've been declined, and we are happen to be in that machine status waiting for acceptance. So self.timer, we will set that to 0. So we'll reset ourselves and go again. We'll go in ourselves into the available state and put ourselves finding some other jobs. Machine status available, and then any other cases we could error out, but I'll pass because there's quite a few other cases that we don't need to handle here, and we'll just again make the logic a bit more detailed, a bit more complete, but not necessarily for the demo that we need to provide today. So this is what it's going. It's just receiving the messages. The three messages that it's really interested in is to say whether jobs are available and append them to the queue, append them to the replies list that then gets iterated on. And then we've got the accepted during the waiting for acceptance, and the declined during the waiting for acceptance states. Either way, we either end up printing or we go back to being available, looking for other jobs. You can see actually the receiving messages here is a bit less than what we have with the job one, but our logic of actually, because there's a little bit of agency here, the machine is going and doing some work on its own behalf based on its status. There's more in that next function. So that is the entire premise. That's all the principles of creating a series of agents, getting their logic set up, creating a world in which they live in, and then they can now iterate through. I guess the final bit is now to test this out and see how it all actually stitches together to create a functioning program. If we go to the main here, what we need to do is name equals main. What we want to do is we want to create the world. So it'll import there. So it's going to import our model. So they're from model.world. We've imported world, created an instance of world there. What we're going to then create is, let's say, create a machine. So let's import the machine. I'm going to give it the ID of 0. And we're going to hand it over the world. So now it's connected. It's going to be linked to the world. World add. I don't believe this is where I think, missed a function, because we want to add the agent so the world knows about the agent. And I don't believe we've got that in here. No. So one bit to debug and remember. But one other functionality that we've missed here is add agent. So, and we receive an agent which is going to inherit base agent. We'll do some debug checks here. So let's just check the agent.id. If agent is in the self dot agents list, then we'll exit and we'll say, agent with ID already exists, and received ID. And then we can go self dot underscore agent. If we're okay, we can add the agent to the list. So into the dictionary, sorry, it's not list. So we're using the ID as the key, and then we're going to pass the agent into it. And then we've got agents by type. And we're going to create agent type dot append agent ID. We're going to say that's a list of agent IDs according to the types. So if it's a job, it'll be in the job list. And if it's in the machine, it'll be in the machine list. I need that, so because I've created the machine, but how do I connect it to the world? Well, then I can do world, add agent, add the agent to the machine, add to the world. There we go. Okay, so now we could just start running some of this as well. Here we go. Let's get the shell up here. So if I just did -main. We've got an import error, so that's good. Let's say we just created some bits. That's before I continue with the demo. Name error world is not defined in base agent. Maybe it does need to be at the top. Yes, so that's what I had initially. So sorry, the error there is to say about the circular imports. That's why I had the type checking in. I know what we're missing. So what we need to add here to do the type checking as well is going to be the from annotations. So you need to import here. From future import annotations. So we are just annotating with world. We're not actually using the world as a function, its functionality. And now we get it to run. So what we are in here is that we're using world for type checking to say this object is of type world, and we're not instantiating worlds. If we put that in without doing the type checking and without this future and annotations bit, we get that error of circular imports because we're importing both files together and they don't know which one to start with. But we don't necessarily need world for this base agent to function. We just want to use it for the type checking, the hinting. Right, so we've got this world with this agent, but it's not doing anything. So let's let's iterate some time, for example, to see what it'll do on its own. So let's go, like say 30 time steps. We're going to do world tick. We're going to initiate the world. So we're going to increment the world time. We're going to then get it to send messages. Let's do that. Plural there. Send message in world. Okay, send messages. Cannot access. Oops. I'll just be okay now. So type check it. There we go. The type checker to update itself, and then world.call next. Okay. What's happening here is that we're going to increment time. We're going to send any messages that we've got in our message queue for that time step, and then we're going to call the next and get all the agents to do whatever they need to do, check what they need to do. In this case, we've just got them in a list, so it'll be the same order every time. In more of these Monte Carlo simulations, you'll randomize the order at every time step that they get called. So we do that. So I'll just run that on the side there. So what we've got here is also, yeah, you should be able to see it, just move my head away. We got machine 0. That's how it is. It's going through next, saying it's available, waiting for replies. It's available, waiting for replies. That's exactly what we're expecting to see, that it's going through the state of submitting to the world, hey, are there any jobs available? The fact there's no jobs there, so it's just sitting, waiting for replies, and then going back into that waiting for reply state after every time available, waiting for reply state. We could, let's do, let's put this, let's split up the formatting for us in a moment, because we're going to add a job, see what happens next. So world.now, and if world now equals say 5, so in time step 5 we're going to create a job. We're going to call this ID1, print time 10, and we're going to also give it the world, and then we're going to add the agent to the world. We need to import job. Okay. This in argument. Type. We don't need to do that. Actually, if we go back to the job, I think we don't need to define that because we define it within the init class, init function itself. We do type equals agent enum dot world equals world equals false, but we don't need that actually because it defaults to false, and ID equals ID is fine. There we go. We can drop that now. We're not going to be using debugs today. So we've initialized that. We just updated there to say the agent.job, the type gets defined by the agent, the top level agent class itself, rather than us having to pass it through the initializer. So now, there we go. So now syntax is all updated. We've imported job. So we're going to create a job at time step 5. We're going to add the agent and see what happens. And let's see what happened. Here we go. So we have our machine states email is available. It's waiting for replies. Because there's no jobs there in the initial time steps, nothing's going to be happening. We are now entering time step 5, where our job gets created, and we can see it, and it's being called by its next state, and it is available. But it hasn't been asked, it hasn't received that message because it wasn't there previously. So it's got to wait until the machine gets to available. And we have our available step. Yeah, so now we're available. We're going into the, it's sent out a message, and it's going to say, look, the job has received that message received. It's going to hopefully reply that. I think it is. And although I've printed out the wrong thing in the machine there, so it's the wrong thing. I wanted it to print out its ID. We can go and debug that in a second. But that's received subject enum available. So we have received that availability. We are still waiting for replies just in case anything else was going to happen. Once we got that, we have now gone into, we'll send out then. We've picked that job. We're now waiting for acceptance. The job has now said it's selected us. That machine has now received that message and it's accepted. And then it enters that printing state. The job is also in the selected state. So they are coupled there in a way. We go for 10 time steps, and then the machine sends out a message to say I've completed. The job receives that message, and the machine goes back to being available. The job is now complete. And now that there's nothing else happening in the world, there's no new jobs being added, we're going to that cycle of availability, waiting for replies. So let's just quickly debug that ID here. And that's machine, and it's in the receiving messages. So it's just that one there. It's an underscore. There we go. So we've cleaned that up. Now we've got the actual machine ID being printed out. Of course, it's the underscore ID that we're looking for there. It's the private variable. So that's agent-based modeling in a nutshell. We have created a world in which our agents, we have a base agent that has the ability to do something every time step, ability to send messages, handle messages. So we have the world in which those agents live in, and then off that base agent, we have created 2 agents, a job and a machine, their own logic, and they're able to communicate through messages and do some sort of logic based on that. So I hope that was useful. Hope that will get you started in some, basic agent-based modeling, where once you've got these fundamentals understood, you can create so much more complexity in how these machines interact with one another, the number of different types of agents. You can add all sorts of variables to monitor, to track, so then you can then plot all sorts of interesting metrics about how they interact when you get to larger scale models. I hope that was useful, and I'll see you in the next one.